Welcome again to the New York City F Sharp user group. It's my pleasure to have Paul here again. This is a sort of farewell tour, so it's all a little bit sad in here today, but really looking forward to learning about ZeroMQ. All right, take it away.
Thank you, Rick. Thank you. All right, so divide et impera, divide and conquer. We're talking about distributed systems with ZeroMQ. And it's going to be a little bit of a longer talk. There's going to be, we do have a code sample we're going to go through. There's a lot of slides. We're mostly going to talk at a conceptual level about a lot of things because there's a little bit of background about myself. One of the many things I've done over the years is I maintain an F-sharp library for working with ZeroMQ, which is a distributed messaging protocol, or sorry, library. But the concepts are really general. The concepts really apply regardless of language. So we're going to spend a fair amount of time up at a slightly more conceptual level because this is stuff you can take to C# or C or Haskell or Java or Node or Lisp or I mean there's even a great binding for ZeroMQ for Racket if you do anything with Racket. So Erlang support. There's a ton of languages support. I'm getting ahead of myself now. So anyway, distributed systems with ZeroMQ. That's my Twitter handle. That is the URL where the code and slides will be. It's not there right now. Give me like a day or so after the talk to clean things up, and that's where it'll be. I'm going to get one big disclaimer out of the way because this one stops a lot of people dead in their tracks. There is no Q. It's not, hey, I could use ZeroMQ. How does it stack up to RabbitMQ? How does it stack up to MQ series? There is no Q. The 0 is for naught, no Q. What you have is you take the messaging and the queuing and you push the buffering out to the nodes in the system, and now you don't tie yourself into a centralized bottleneck. You can add that if your architecture requires it, but you're not tied into it. You don't license ZeroMQ from a vendor. I like to joke, it's not something that comes in a 1U rack mount. Like, it's a library. That's it. It's a library. It's also open source. The Z is for zero is for not. So no message queue. Now that we've cleared that up, what actually is ZeroMQ? Well, so first and foremost, ZeroMQ is this awesome, awesome community of distributed systems enthusiasts, hobbyists, professionals, people who are very passionate about this. They primarily communicate through the mailing list, sort of a little old school, but it works. Everybody has email. Everybody can go to a Google group or Peppermail or whatever. And they produce some other stuff like the Z Guide and some books and whatnot, but that's the community. The community spends a lot of time focused on protocols. What protocols are these robust, evolvable, language-agnostic specifications of how to build distributed systems, how to exchange information. The primary one is ZMTP, the ZeroMQ message transport protocol. It's where we're going to spend most of our time looking because all of the other protocols are most of the other protocols, I should say, are sort of built on top of it. The ZeroMQ community is very big on protocols, very big on this idea of give me a specification that is language agnostic, that is technology agnostic, that I can refer to, that I can code to, that I can make real and bring around. And then of course, they've built lots of libraries and additional tooling on top of the various protocols and specifications. The two we're going to look at are FSZMQ and libZMQ. libZMQ is the sort of the granddaddy of all the libraries. It's the canonical C++ implementation and sort of the first library. FSZMQ is an F-sharp wrapper over libZMQ that makes it really pleasant to use in .NET. It's got stuff for some C# support in there and some VB support and some F-sharp support. And that's mostly what we're going to be looking at today. But all of the concepts in FSZMQ really do have a very close, for the most part, a very close similarity to the underlying concepts in libZMQ because it simply wraps it. libZMQ being a C library means you do need to have the appropriate version for your platform. That's life. There are other implementations of the libraries that are written purely in managed code, platform agnostic, what have you. As a sidebar, there are 3 in particular .NET libraries. There's FSZMQ, there's NetMQ, and there's CLRZMQ. NetMQ is 100% C#, fast, full-featured. The API is a little C# biased. There are some features it doesn't have. It lags a little behind in terms of features as compared to libzmq, but it's actively maintained. It's a pretty good library, and it's 100% managed code. Does not run at all on Linux. CLRZMQ runs fairly well on Linux. It's a C# wrapper over libzmq. They, as near as I can tell, update it approximately whenever the hell they feel like it, and it generally doesn't have great support and has a fairly Byzantine API. Does run well on Linux, but it does sort of dodgy things like embedding and then dynamically emitting and loading the CDLL and some other stuff that sort of gets a little hairy. FSZMQ does not do any of those sort of tricks. My slide notes say it has poor Linux support because up until very recently it did, but I found out through happy accident that if you use mono on Linux with FSZMQ, you will have a horrible time. Works great on OS X, works great on Windows. Sorry, Mac OS, we're calling Mac OS now. Works great on Mac OS, works great on Windows. Didn't work so great on Linux with mono. However, it turns out, I'm getting reports from users, from people out in the field that with .NET Core, it just works. So we don't technically have development time support for .NET Core in FSZMQ, so you have to wind up bringing in mono or .NET Framework at development time, but at deployment time, you can just deploy your DLLs that use FSZMQ on top of .NET Core, and everything works pretty great. So works pretty great, and so there's that. So I have to change my slide that we do somewhat have good support on Linux if you use .NET Core. Nice to know Microsoft completely ignoring that the rest of the .NET ecosystem is good for something. So some examples where it has been used in the wild. Lots of places, you can do lots of things with it. Some companies that are known users of it include AT&T, Cisco, Electronic Sports, Los Alamos Labs, NASA, CERN, Microsoft, lots of people. Everything from sort of virtualized infrastructure management, the cloud, live indexing systems, microservices, distributed caches. Some people have built web servers with it. I don't know that I do that. 3 particular .NET implementations that are interesting, in part because I've been involved with them, in part because I know that they are .NET implementations. Remote execution, job systems, event sourcing platforms, and started right here by Bedrock, polyglot scientific notebooks. I mean, not started, but the F# support for polyglot scientific notebooks, basically Jupyter notebooks, started by Bedrock, uses ZeroMQ internally. That's how they're able to get Python and Julia and F# and Haskell and all these other languages all playing together in the scientific notebooks with all using the same front end with all those different backends. Because they leverage ZeroMQ, because one of the best things about ZeroMQ is it has broad support for many technologies because nothing about it is technology specific, aside from sort of the unavoidable, like TCP works this way, so we do these certain things with TCP, but that's not language specific. A note on nomenclature, and then there's sort of some more boring things that people have done, obviously things like log aggregation, stop tickers and whatnot. We're gonna look at a chat system today. Chat systems are kind of boring, and truth be told, I might use ZMQ as part of a chat system. I don't know that I would build a very super robust chat system on top of ZMQ just because there are lots of other alternatives. But what's nice about chat systems is it's a real world enough domain to offer interesting problems and interesting concerns and throw some nice challenges. It's not a toy domain, but it's a simple enough and well understood enough domain, I think, that we don't get caught up in the nitty gritty details of the domain while looking at the actual code. You know what I mean? A note on nomenclature before I dig in further. Generally speaking, if I say ZeroMQ, I'll be talking about the community as a whole and sort of the general concepts and that sort of stuff. If I'm talking about ZMTP, if I specifically mean the protocol ZMTP, the formal specification. If I say ZMQ, I'm typically talking about libzmq and FSZMQ and sort of the concepts in those libraries. So That having been said, any questions before I start to dig in a little bit? Awesome. Cool. So there's three main concepts to concern yourself with in ZeroMQ. You know, if you wanted to one sentence it, context collects sockets which exchange messages. So context is sort of this big, heavyweight housekeeping object. You typically will have one per OS process. You can have more than one per OS process, but they form sort of an isolation boundary. So if I had an application with two contexts in it, it's like two separate applications. So if you've done any .NET, it's sort of like multiple app domains. It's a very strong context boundary. In fact, a lot of times for rapid prototyping, I'll crack open an F# script file. I'll spin up two separate async loops that each have a context to get some client-server type prototyping going on. When I'm ready to bring it to a real app, I can just take those, copy them out to separate actual projects, and I'm on my way. So it is useful, but primarily in deployed code, you have one context per OS process normally. Basically, the context's main purpose is to do some housekeeping and manage sockets. Sockets are really your workhorse in ZeroMQ. You'll create potentially many sockets. I mean, the simplest application will have two sockets. Two sockets together form a channel. You can't really do any distributed anything without at least two, right? It's that joke. It doesn't strictly apply here, but it's relevant. You talk about agent-based systems, actor-based systems. A system of one actor is no system at all. The same idea goes here. You're going to have at least two sockets, one on one end of the channel, one on the other end of the channel, as messages flow between sockets. Sockets specify a lot of things. They control the message exchange patterns. They control what happens when queues get full. They represent into these opaque, inaccessible, sort of internal buffers of messages, inbound and outbound. They manage connections to other sockets. They do a lot, so you spend a lot of time with them. The messages themselves that the sockets are passing, extremely simple, simplest thing that could possibly work. One or more frames of 0 or more bytes, with just straight bytes. It's up to the application to decide what the bytes look like, what your encoding is going to be, what your framing is going to be. That's at a very application level concern. So none of this, you must use protocol buffers, or you must use JSON, or what have you. So it's very much raw data, which is nice because you do a little more legwork up front, but you also do a little more thinking up front, and you get things that are typically a bit more of a better fit to your purpose. And when you need to, you can get a lot of performance out of working directly in bytes. So the last thing that's sort of a less interesting detail, ZeroMQ abstracts over transports. There are some cases where this abstraction breaks down, but for the most part, you'll write the same code whether it's going over TCP or named pipes, or if it's purely in process for multiple threads, or it's going over norm or EPGM or what have you. Generally speaking, you'll change your connection string, and other than that, the rest of your code is the same. So that's sort of not a huge issue, but it is something you have to keep in the back of your mind because obviously, depending on what transport you're using, your infrastructure has to support it, and you might debug things a little bit differently if you're going over TCP than if you're using PGM and things like that. So these are the main concepts when working with the library, but it turns out you don't really spend a ton of time on these things. It turns out a ZMQ application really focuses on some different things. And the first of these is socket roles. So we talked about sockets. Every socket has a role, right? And what is a role? So a role is basically a configurable bundle of behaviors for that socket. It'll be things like the message exchange pattern, whether you can send or receive, or both send and receive. Is sending and receiving synchronous? Is it asynchronous? How do you can connect multiple sockets to multiple other sockets. So the socket role will determine, am I doing fan-in? Am I doing fair queuing? How am I dealing with receiving messages from multiple peers? Every socket that's connected to a particular socket gets its own queue for inbound and/or outbound. So the role will determine, what do I do when my queue is full? What do I do when my queue is empty? Do I block? Do I drop? So on and so forth. There are quite a few different socket roles, and different combinations of them are valid. Some combinations are invalid, and that's sort of where you spend more time thinking, I'm going to use these two socket combinations here, I'm going to use those two socket combinations there, what have you. In this talk and in the code we're going to look at the 4 most common, I would say, socket rules. Certainly not the only ones, but the 4 that will get you sort of, that your 80-20 rule, right? Like 80% of your time in these 20% of your sockets. The first of which is bidirectional sockets. And there are really 4 bidirectional sockets, depending on whether you want a synchronous channel or an asynchronous channel. So synchronous peers would be a rec socket and a rep socket. Request, reply. So we can't, couldn't do request response because that might be confusing for people who do HTTP, whatever. Anyway, this is a very simple send and receive model. Request socket sends a request to the rep socket sends a reply. When we say synchronous, we mean that once a rec socket sends a message, the only thing it can do is receive a message. It can't send multiple messages and then receive a message and then send a few more messages and then receive a few messages. It's strictly send then receive, send then receive. The rep socket is the inverse. Receive then send, receive then send. That may sound very limiting. In a lot of scenarios, it's exactly what you need. It's the simplest possible thing. It is not always useful, which is why we also have asynchronous peers, a router and a dealer. And those should actually be inverted because dealer is logically the asynchronous extension of a rec socket. A router is the asynchronous extension of a rep socket. And what router and dealer do, very similar, except that you no longer have this strict send and receive staccato sort of dance. You can send messages, you can send 10 messages, receive 2, send 1 more, receive 6 more. You can implement a dealer that just sends messages and doesn't receive at all. Like, you have full asynchrony. The other cool thing, you can chain things together. You typically will have, you typically can't chain things to rec and rep, you put them on the ends, but you can put as many routers and dealers together in the middle, and this is where you get your intermediaries, your proxies, so you can build very interesting topologies, chaining together synchronous and asynchronous bidirectional communication.
If the order doesn't matter for asynchronous peers, what's the difference between router and dealer?
We will get to that.
Okay.
The major difference is because order doesn't matter, you receive additional information in the message that tells you who sent it to you so you can decide how to respond. And the way that information looks differs from router and dealer. There's also a concept of socket identity. Routers typically don't, they can have an identity, they typically don't. Typically you'll set the identity on the dealer. Effectively something has to initiate, so.
So routers can't initiate.
Routers can, they typically don't.
Okay.
If they were to initiate, it would have to be to a known hard-coded identity, so that's why it's a little tricky. You know what I mean? It's like, I have to have your phone number before I can call you, unless you've just had, plastered your phone number everywhere.
Gotcha.
So that's basically that. The other major kind of socket role that you spend a lot of time with is what we'll call broadcast sockets, or more commonly pub sub. This is your, publisher and subscriber model. One publisher produces messages to 0 or more subscribers. It nary cares how many subscribers it does or doesn't have. What makes PubSub interesting is, aside from the unidirectional flow of messages, publishers can only send, subscribers can only receive, messages here are subscription-based. They have what's known as a topic, which is a filtering mechanism. So a subscriber says, I'm going to connect to this publisher, but I only want messages that have topic XYZ. So it only gets those messages. So in a lot of ways, the conceptual model here is a radio broadcast, right? I turn my radio on, and then I tune into the station that's playing what I want, and I get whatever's being broadcast from the point that I tuned in. So PubSub, I think, a fairly well-understood concept. But this is for one publisher, many subscribers. We need to do something slightly different if we want many publishers and many subscribers. And this is, we introduced this concept of XSub and XPub. And in the same way that router and dealer make synchronous things asynchronous, XPub and XSub, they add a tiny little extra layer to things. They forward the subscriptions effectively. Because if you have multiple publishers and multiple subscribers, your publishers need to know what the subscribers' subscriptions are. And so XPub and XSub, you glue them together, stick them in the middle, and that takes care of making a many-to-many connection. We won't actually see an example of of xpub and xsub in this talk, but it's good to know about. We also really won't see an example of router and dealer, or rep and rec, because they don't fit our model. When we get to our actual example, we'll mix pub sub and router dealer, because it turns out those are really the 4 roles you spend most of your time with, because they do a lot. Questions? All right, if I'm moving too fast, oh, but
I
yeah,
have a question. So with router and dealer, xsub and xpub, are these would be things where you have intermediate nodes?
they could be.
Or
Certainly
are they endpoints, or?
Certainly for xpub and xsub, it's typically a proxy. It's typically a thing you stick in the middle, and its only real feature is it's a known stable node in your topology, and it doesn't do very much but shuttle things from A to B. You can use router and dealer in that way. You can also make the router and dealer the actual terminuses of a channel and use them directly. You typically use pub and sub as the terminuses and treat xpub and xsub as just sort of these very naive intermediaries whose main property is they're well known. So you have your few stable points in your topology so that the bulk of your network can come and go arbitrarily. And you don't have to manage, 100,000 connection strings. Good question, though. If I'm moving too fast or we want to go back to something, that's fine too. Totally informal here. So we talked a bit about roles. The other major thing, because ZeroMQ is so lax about what a message should look like, you spend a fair bit of time talking about message framing. Effectively, we can have 1 or more frames of 0 or more bytes. What are we putting in there? That's an application level concern. So in the process of building a ZeroMQ application, we actually spend a fair amount of time thinking about it. And so what's interesting is this is where socket roles come back into effect. The same message will look a little bit different to different socket roles. For pub and sub, not so much, but for rep, router, dealer, yes. And this is worth sort of appreciating. If we have a simple message that is 3 frames of content, so however we've chosen to break it up, we have 3 distinct binary blobs that each represent part of our content. A rec or rep socket is just going to see those 3 frames, and that's it. They're just going to see the content. A dealer socket is going to have this extra additional prefix frame that basically says, hey, everything from here is the routing envelope. And then, of course, a router will see more information in the routing envelope. Now, I've sort of oversimplified here a little bit. Routing envelopes can get stacked on top of each other. If you chain together many router dealers in sequence, you'll start to see more and more of these pure identity frames get stacked onto the routing envelope, and at some point they do become visible to the dealer. But so that's, to answer the question, that's the big sort of thing with router and dealer. You have this routing envelope, these extra frames of information about the other nodes you're communicating with that you can then use to make intelligent decisions. And we'll actually see an example of this in our chat application where we will use the routing envelope to identify our clients. But this is the same message but viewed differently by different socket roles. So that sort of becomes important. Questions about this? Yes?
Is the pure identity sometimes used as like a user definition so you know who you're dealing with, or is it just used to return the data back?
It can be either.
Okay.
If you do nothing with it, by default, out of the box, if you do nothing with it, the ZeroMQ just treats it as a return address, like, hey, this is where this message goes. But you are free to fully grab it, inspect it, set it, do what you want with it, and treat it as actual data, which our chat application will do. So you are free. Routing envelopes, it's worth noting, again, that routing envelope as a concept really only applies to router and dealer. Same for identity. You really only have identity in the bidirectional socket space. Pub sub identity doesn't make any sense because you don't have bidirectional communication, you just have topical filtering. But it folds into message framing. Sort of switching gears for a minute, and maybe it's, sort of switching gears for a minute. Why are we not? Hello. There we go. Routing, the framing story looks a little bit different. Routing, what you'll wind up with is, subscriptions. Sorry, pub sub, subscription-based routing. Apologies. PubSub, we talked about messages having these topics. Well, it turns out, again, ZeroMQ takes or ZeroMQ takes a very pragmatic and simple approach to topics. It's a simple prefix match, which means when I subscribe to a topic, my topic is the first n bytes of a message. So that offers you a lot of flexibility. It also leads to a fairly common pattern of one frame for the topic and one frame for the content, one or more frames for the content. But, I mean, it's pretty flexible. To see an example of that or to understand it, let's say we have a publisher that's publishing many, many messages, but all of the messages have one of these 5 topics. So the first n bytes of any one message will be antique, antelopes, and an ant, one of those words, right? So if we, in our subscriber, set a filter of and, we will receive messages that have any of the topics, right? Because prefix matching, all of the topics start with an. If we set a filter of ant, well, now we're only going to get 3 messages with one of 3 topics. And if we follow this out logically, if we set it to anti, we're only going to get messages with the topic antique. And if we set it to ant2, we're not going to get any messages because we have nothing that matches. So, does that sort of make sense? Cool. So, the third thing that sort of ZeroMQ application developers concern themselves with is the notion of protocols, which is effectively, we pick some roles, we have some framing for our messages, we have obviously the definitions of some messages that we want to pass between those roles with the framing, we bundle it all up, write it all down, boom, it's a protocol. So that's the other thing. The protocol we're going to look at in this talk is a very simple protocol called chat protocol. I don't actually have a clever acronym in mind for chat. I wanted one and I couldn't come up with one, but the point is it's many clients connecting to a single server, so we're going to use dealers to connect to a router. We're also going to use publishers, a publisher with many subscribers connected to it. A typical flow might be a client sends an idle message, a server responds back with an acknowledgement, or a client sends a news message, a talk message to the server, or the server sends a news message, broadcasts a news message to clients. And we have some notes here about our protocol. Talk and news can occur at any time. The expectation is that because we are using topical filtering to broadcast our messages, a client would subscribe to basically messages from the chat server for group broadcast or their own handle for things that are directed right to them. So that's just sort of a high-level sketch of the flow in pseudo-AVNF type things. If we look at more pseudo-AVNF type things, these are our messages. We really have 4 different messages that we send. Our client will make 2 different requests. Either it will make a here request, which is just a simple keep alive, heart beating, hey, I'm here, don't forget about me. Or it'll send a talk message saying, hey, I've got this message I want to either send to a person or share with everyone. The server, when it receives a heartbeat, will send back an acknowledgement, which is list, or it'll broadcast news. It'll broadcast a news message out to subscribers. The individual pieces of data here, if you think of this as sort of is everyone familiar with BNF grammars and eBNF grammars? It's just a shorthand for describing a language. So what we're saying is a here message would be the signature, followed by the version, followed by the protocol, followed by the literal byte 01 in hex. And we're saying down here, signature is actually 2 bytes, 4D, 4F in hex. Protocol is actually 4 bytes. Version is a single byte. So effectively, your here message is a single frame of 8 bytes. Just boom, boom, boom. For talk, list, and news, each message has 2 frames. There's one frame that is the sort of control frame, that is again these 8 bytes that sort of tell you what's going on, and then a second frame that is a blob of UTF-8 encoded JSON, just to show that we can do some interesting encodings and have some more mixing, sort of purely working at the byte level with taking some higher level encoding. And what's nice about JSON is it's cheap and forgiving and ubiquitous, and in F# it's very, very easy to work with. And even in C# or VB, it's not terrible to work with. There's no reason it would have to be JSON. You could use anything you want, really. The original use case for libZeroMQ and for ZeroMQ was ultra high frequency or ultra low latency messaging for high frequency trading. And in those scenarios, they use 100% binary bespoke hand-rolled message parsers because that way they can squeeze optimal performance out of things. So you really have a lot of flexibility. The news message is worth considering. It's a little bit different because here talk and list are going to be part of our router dealer bidirectional exchange. News is going to be our topical broadcast from pub to sub. So our topic that we're subscribing to is really this first frame, signature version protocol and then topic, and then the body of the news announcement, the body of the broadcast is the second frame, which is this UTF-8 encoded JSON blob. And what we're saying here is the topical portion at the end of the frame is either going to be a literal string or the client's handle, the nickname they're using. And note, ZeroMQ routing envelopes, that routing envelope I was talking about, that's technically present. There's technically 1 or 2 frames above talk list in here. I'm not showing that on here because it's just easier. Questions?
Is there any limits on the size of the frame and how you compose a list of frames?
Yes, the limit is the entire message, meaning all of its frames for a single message, must fit in memory. So you are bounded by the operating system memory of your process and your OS. An individual frame itself can be as big or as small as you want it to be, from 0 byte, from an empty frame, to as large as will fit in memory. Obviously, if you have one frame that is so large that the whole frame, you can't, you know what I mean? Like that's your limit. All the frames of a single message have to fit in memory because ZeroMQ, I forgot to mention, guarantees atomic message delivery in that you will either get all of your multi-part message or you will get none of it. You'll never get half a message. You'll never get the first 2 frames, not the last one. You'll either get the whole thing or none at all. And the way it guarantees that is, or part of that guarantee is, well, you have to be able to fit all the frames for one message in memory. Obviously, it's only for one message because you could just have that much space allocated to messages, reuse it as a buffer. So, yeah.
Is that what FileMQ is for something like big stuff?
Mm-hmm. FileMQ, yeah, is a protocol built on top of ZMTP that defines how to take a really large thing like a file and chunk it out over many messages, and that way you can stream it out and maximally keep the buffers full and everything like that. But yes, because it's naive to take one message, one large file, and try and just blast it out as a single message, even if you cut it into multiple frames. So yeah, FileMQ is a protocol for that. It also does syncing, or not syncing, but it lets you set subscriptions on paths, so it'll do syncing, like give me all the files at this path kind of thing.
Oh.
But that's an additional feature. The other part of it is the streaming of the large files. So it's actually quite interesting. It's the model they use is what's known as credit-based flow control. So for a given consumer, a producer has a max total number of credits that consumer is allowed. And what a consumer does is each request is 1 credit. It basically, so it'll let's say the credit is 3. It'll make 3 requests, and then it will make its next request until it starts getting stuff back. Like it's run out of credit, so when it gets another message back, okay, it gets the first part of the message back, I've got a credit again, I can request another message. So that way, the server doesn't get overwhelmed, the consumer doesn't get overwhelmed. It's actually a pretty nice model when it's working correctly. So, and it's obviously applicable to other message exchange systems. Like I've seen people do things like that with mailbox processors in F# and with Erlang processes and so on and so forth. So, additional questions? All right, so we're going to look at some more specific messages. So we've got our topologies, our servers in the center, and then we've got all these clients that connect to it. And the server does keep track of clients because it's no fun sending a message out into ether and hoping people listen to it. I mean, that's what Twitter is for. This is a chat application. We want to know who's there, who we're talking with. So it's not persistent in any sense. It's all in memory. But we do keep track of clients. And the way we do that is our dealer, our client, will send a here message. And we'll make a note of their identity, which is going to be in the routing envelope. And then we'll send back a list message. And the reason why it's called list is because it's got this control frame, but But then the payload is actually a timestamp, because it's good to have timestamps in UTC, and then a list of handles, a list of everybody who the server currently knows about, so that the client can decide, oh, I'm going to send a message to Rick, or, oh, I see Steve's here, you know what I mean? Because otherwise, again, we're just shooting things into the ether and hoping people we want to hear them are there. So server will keep track in that way. These extra bytes here, that's just to sort of help disambiguate, because obviously we do have the option of security, of authentication and authorization, but it's a little complex for an intro, so we're not doing any security. So putting some sort of disambiguator on our protocol just makes it easy for us to have some control and some flexibility. Like, hey, I know that I'm on version 3 of this protocol, and I only accept clients who speak version 3. Or, hey, I accept clients who speak versions 1, 2, and 3. So, like, having a little bit of flexibility there is sort of why we have a little extra disambiguation in the protocol, as opposed to just sending, like, the here byte. Yeah?
Would you subscribe to 3 different topics in that case? 1, 2, and 3 topic? Signature plus 1, signature plus 2, signature plus 3?
If you were a client that wanted to communicate across all 3 versions, yes. Because the disambiguation is going to want to be part of the topic. So yes. In fact, we'll look at that right now. The framing for news messages, we talked about this a little bit, but this is just showing it in more detail. Again, you would have the signature and the version, the disambiguation as part of the topic. So yes, you would have to set multiple subscriptions. And then our payload for an actual message is who sent the message, timestamp, and then just a string of the actual message, just something simple here. The goal is not to build a Slack replacement, it's to demonstrate distributed computing. So there you have it. And obviously we use a very simple algorithm. If the sender is $chatserve, it's a group message. If the sender is anything else, it's a private message from that person to you. So pretty simple algorithm.
Quick question about
Yeah.
dealers. So when the router receives the address
Mhm.
of the dealer, what sorts of detection mechanisms can ZeroMQ provide to detect the liveness of that dealer? Do you need to build your own heartbeat protocol and
You build
presence
your,
system?
you do your own.
Okay.
It will do, if you're running over a connected protocol like TCP, it will at the transport level handle things like reconnects and things like that for you. However, at the ZMQ level, you need to build your own heartbeating protocol in, and that's effectively what we've done with the here and list.
Will it silently drop the messages, or will it give you some errors but not always for things that are just sort of slow to fail?
I don't understand what you're asking.
You know, TCP connections can sort of be held in limbo for a while if the thing just disappears in
Sure,
a
sure.
not so happy way, right?
Yeah.
Rather than a connection just being literally closed. So is there something ZMQ provides to help detect that beyond just, it seems like you need your own protocol anyway, but does it give any sort of signaling?
There are times where it can detect a TCP connection stall or drop or whatever, and will raise an exception for that.
Okay.
But not always. Sometimes, unfortunately, you still only realize it because of silence on the line.
Yeah, no, it's still a distributed system.
Yeah,
You
so-
know, RPC concepts.
I'll say it falls somewhere, the support ZeroMQ gives you falls somewhere between doing everything yourself at the raw TCP level and doing nothing. You know what I mean? Like, it gives you some help for some scenarios, but there are still some scenarios where you have to have your own heartbeating protocol in place.
Cool.
So, sort of a side note, one interesting sort of variant on this is if you've done any work with Erlang, there's a tool called ErlExec that runs on POSIX operating systems that actually hooks into POSIX signals to provide Erlang's process trapping for external processes. That's something you could combine with ZMQ and Chumac, which is the Erlang implementation of ZMTP. You can combine those to get some pretty interesting results in that space that are slightly better than typical because you've got those extra POSIX signals, but you're out of luck on Windows. POSIX? Who needs POSIX? We're Microsoft. Okay, so are there any more questions about this before we move on? All right, cool. We're going to get to some code in a few minutes. High-level schematic of what our actual application looks like. Here's our server with its router socket and pub socket. Here's two instances of our client with a dealer and sub. And you'll see router and dealer are bidirectional. Pub sub is unidirectional. And at a very, very abstract level, this is what our messages look like. So a 2-frame message a 3-frame message, and a 4-frame message. I call out the number of frames in the message because part of dealing with ZeroMQ is you'll get a bunch of frames of bytes, and then you have to decide how to parse them and what to do with them. And a cheap and easy validation is, I'm expecting a 2-frame message. Did I get a 2-frame message, or did I get a 3-frame message? So it's sort of a cheap entry into sort of simple parsing. Okay, so let's go look at some demo code. If PowerPoint ever wants to, PowerPoint wants to give my computer back. So before we go actually look at the code, let's actually run the example. So we'll start our server. Where am I? Seriously? Bash fail. So our server is just a simple command line server. It's listening, on TCP on ports 2203 and 2201, and we're just getting a little diagnostic message because right now nothing's connected to it. So it's just saying, hey, I'm here. No one's listening to me. Obviously, in a more robust application, this would be a configurable logging thing that you would turn off in production. I'm just writing the standard out for logging right now because demonstration. But let's fire up some clients. So I happen to have a client here. The client asks you for your handle because who are you? So I'm going to tell them my handle is P. Blasucci. And boom, now I have one client connected to my server. You can see my client is sending here messages, and it's getting list messages back, which is why I'm able to see my name in that column on the left. Maybe not terribly interesting because just one client, but if we add a second client, now things get a bit more interesting. You can see a couple of things happening now. One, I've got 2 clients, so I'm getting multiple handles back in my list. I'm displaying my list on the left here. 2, you'll notice we've got these welcome messages. Those are not initiated by a client. That's coming directly from the server. So you start to see we've got this notion of messages don't have to be this round-trippy HTTP request-response client-initiated flow all the time. You can have a persistent connection and have servers just start spitting things out. But let's send some actual messages to the group. Boom, and now you'll see we get a message to the group, but we can also send private messages. And now you'll forgive me, I haven't written in notification for private messages, so I'm not going to send a message to myself because that'd be kind of silly. I mean, I could do it, it works. Bonus points if anyone gets the reference. And you can see it's sort of just a private message to yourself, which, why round trip it through the server? I mean, whatever. But let's say I want to send a message to Rachel. There you go, see? And you can see we have private messaging. Those messages are not part of what goes to the group. So that's the sort of 20-second demonstration of the chat app before we go in and look at the actual code questions. And obviously, if I do something like this, and we wait 5 seconds, because I've set the client lease to be 5 seconds, you'll see an expiration message. The server noted that it hasn't gotten any activity from the client in 5 seconds, and we've updated the client list because the next message, the next ping acknowledgement that went out to the client didn't have our Reese in the list of connected users, and we got this little goodbye message from the server. So there's an example of sort of the heart beating, sort of, well, we didn't hear from the client, so we consider it done. And of course, there's nothing stopping the client from just reconnecting, if I gave the window focus. And for people wondering about the awesome styling of my chat client, yes, I am running a WPF application in Unity mode on a Windows 10 VM via Parallels on a Mac. So you get this, you get this awesome ghosting on the side there, and it looks all crispy and whatever, but I challenge you to find me any other GUI toolkit that doesn't require installing Node. Since apparently that's the only way we can do GUIs now is via Node. I don't know who made that decision, but I wasn't consulted.
Well, there was a meeting.
Anyway, so cool. And
What
then,
happens if you start a second client with the same name?
that is a fantastic question. Let's conduct an experiment. I like experiments. Oops. Welcome, Ashley. This actually should cause an error. There's a tunable feature in ZeroMQ to say that if you receive, because now what I hadn't showed you yet, but I mentioned, we're using this handle that we enter to set the identity on our client dealer socket. There's a configurable flag in ZeroMQ to say, hey, if you get messages from more than one socket with the same identity, treat it as a transfer. Consider the old socket dead and start transferring messages to the new socket. But by default, it's an error. By default, it says, so we should. Yeah, see, we get nothing. Again, because WPF and because I didn't set it up very well, I'm not actually, the error is being trapped into the ether, but the reason why we have nothing here is it's not communicating with the server because it failed to establish a proper connection, because I don't have that flag set. That's a socket option I could flip. Does that make sense? Not an unreasonable set of defaults. Additional questions before we look at the actual code? All right, cool. So now source code. So we're going to look at the server primarily. We can look at the client if there's time, but technically I'm not supposed to show you the client code, so we may turn the camera off when it comes to that. But we can look at the server code. The server is a very simple F# command line program, just a standard. I went into, create new project, template is console application, and I'll show you it. It's primarily 4 files. I also have an FSX, a Scratch FSX file in there for just playing about. I've got my app config and my assembly info, and the standard things you would expect to see in an F# project, but it's just a simple F# console application with 4 files. Library's not really interesting. This is my sort of auto-open catch-all at the top of my library, at the top of my code, where I define all of my shortcuts and whatnot, and things that, I think required qualified access was way too wordy, so I'm shortening that to qualified, and so on and so forth.
You're using measures.
Yeah, and nothing really useful. These are just little helpers. This protocol file, also, I have them arranged this way on purpose. I don't have the version of INI, the latest versions of INI. Oh, I do. I'm sorry, I lied. There's the Project Explorer. It's much more interesting to look at from the Project Explorer standpoint, because the Project Explorer standpoint will show you the actual project file and then the actual order of things. So I had them arranged in their actual dependency order. Obviously, so there you have that. I don't know why library got closed, but let's reopen library. So I'll put them back here. So from the bottom up, because that's actually a really good way to explore F# libraries until they take away our forced ordering, which they keep threatening to do, and I keep saying, no, forced ordering is good. Circular dependencies are bad. We start at program. So what is program? Well, starting at the bottom, working our way up. This is our actual program. This is our main entry point. This is our main function. It doesn't do very much. We're using the argue, is argue or argue? I never know what the right way to pronounce the library is, but Eric Sarpalis, who's an awesome guy, does really cool stuff, created a really cool library for parsing command line arguments called argue. So that's what we're doing. Here, we're defining what our arguments are, and it's really just the configuration things we would need. What's our host IP address? What port are we going to listen on for receiving requests? What port are we going to publish broadcasts on? How long are we going to consider a client idle before we consider it dead? And how long do we wait? Timeout is interesting. So the API for ZeroMQ, for ZeroMQ and FSZeroMQ can send and receive in either a blocking or non-blocking fashion, which has nothing to do with synchronous or asynchronous messaging. It just has to do with how long you wait to hear if you got something out of the buffer. You can do blocking, and then it blocks indefinitely. This timeout just gives you a setting for, hey, only wait for this many seconds, and then come up for air and let other things have a chance, and then go back. And the reason why we do this is so that ZeroMQ doesn't get greedy and block the entire message pump, and then you can't interrupt your application, and you can't exit, and your screen doesn't refresh, all this other stuff. So that's what timeout is. So we're setting up our command line args. such as they are. I define a couple of literals because I choose to. We create an arg parser, and then our entry point is our main function. In a try catch, basically we parse the input and we build an instance of our server config object, which really just checks the parsed results for the parameters. And if the parameter is missing or wasn't provided, we use a default that we've hard-coded in the system. So pretty straightforward. And then we bundle up our configuration object and we pass it to the server along with this nifty little function that does our diagnostic tracing for us. In this case, I'm just writing to standard out, but this is really any function from string to unit, so go nuts. And then server is the actual meat of our questions about this before we look at the actual server. So basically, our first file is program. It just sets up the shell. It just sets up the console application, hooking it to standard in and out, and basically getting configuration input from the user. So like I could, for instance, go to the command line and do this. And then, well, I don't have localhost set up on this machine, but that's besides the point. You could do this even. And this is all stuff that's powered by argue, right? It's just options. So that's all that is. Questions about that before we move on? Super. So the server itself does our actual work.
Oh,
Oh yeah.
it never returns?
It returns when you interrupt it by hitting Control
Sure.
C.
So you never get to OK until you're done.
Yeah, you don't get to OK until you throw the actual system interrupt. So technically, you never actually get to OK
Gotcha.
because the system interrupt actually shows up as a fail that gets trapped, and then but that's because .NET uses exceptions for control flow, which whatever. I heard somebody once say that was bad. Apparently, nobody in .NET land listened. So yeah, we never actually technically get to OK, but it's good to have it there. Interestingly, this is the simplest possible version of this. A more complex version would actually spawn the server via async, a background thread, and then what you would do is you would create a cancellation token source, hook that up to the Control-C, sort of the cancel key press event, and use that event to cancel the token source, and then you would get a clean shutdown. You still need to trap because under the covers, async, and in fact all threading in .NET actually aborts by throwing exceptions. So you still need to trap, but you would get a clean shutdown there. But honestly, I feel like at the OS level, as long as the process respects, as long as I don't have to force kill it, as long as I don't have to go to like SIG-abort, or SIG-fail rather, if it respects SIG-abort, I consider that clean enough for me, right? Especially for these purposes. This is not some server that I'm running in production trying to have a multi-billion-dollar company on. So the server itself, we define a record to hold our config. That was the thing we just populated in the program. We have some sensible defaults here. 1 second for 1 second for polling, 5 seconds for client lease, some different ports, and by default binding to localhost. So whatever. We define a couple of literals. This is just a diagnostic message that we display. This is the actual name of the chat server for when we're doing group stuff. And then we have our whole program is really just this one function. So this is our main function, this run function, right? It takes in an instance of our config, and it takes our tracing function, which is any function from string to unit. That way I can cheat and just pass it printf because I'm lazy. The main thing we start with is by configuring ZeroMQ. So we'll go ahead and create a new context, which, like I said, we typically have one context per OS process. We'll then go ahead and create 2 sockets. We'll create a router socket, and we will create a publisher socket, right? So control and publish are our router socket and our publisher socket, right? After we've created our context and our sockets, we bind to the addresses that we set up in our config. So our control socket is bound to one address, our publishing socket is bound to the other address, and then we emit diagnostic messages just so we can see what we've got. Pretty straightforward. Now that we're set up, we can fall into a recursive loop. Before I dig into the details of the loop, I'm going to show you the rest of run here. So run is really simple. You have some very procedural sort of setup for your I/O, and then you have your you run your loop. And your loop is a pure, well, not entirely pure, but mostly pure recursive function that does the actual work, taking in 2 bits of state. The 2 bits of state it takes in are actually date time, which now is now, since I recently read a thing where I was told that, and this makes sense, date time is sort of IO and there's a side effect, so pure functions can't be calling get date or whatever. Anyway, and then clients, which is, this is our internal state mapping our clients. It's just a simple dictionary from the client's handle to the point in time when they expire. And I'm just using a simple date time in UTC to mark, hey, they will expire 5 seconds from now. Date time was the easiest way to sort of do that. So my actual loop is broken into a couple of very distinct parts for reasons. The first is we need to call any expired clients. So what we do is we take our map, we split it into clients who are live and clients who are dead. How do we do that? Well, we look at now and we look at when the client is set to expire. If the client is set to expire after now, they're obviously still alive. If now is a more recent than their expiry time, then they're dead. So that gives us 2 separate lists. From there, we loop through the dead clients. We emit a diagnostic message, and we publish that goodbye greeting out to that goodbye message out to the group that we saw. Goodbye, R. Reese. Goodbye, Blasucci. That's the lines 42 through 45 here. So pretty straightforward. What we're doing to send that message is so dead is our map, right? Map can be looped over as a collection of key value pairs, which is what the key value active pattern does. We're binding the handle as the key, and we're binding the expiration to expiry. We use that to sort of print out our statement here. Then what we do is we take the handle, we format it into a goodbye message. We have this protocol library, which I'll get to in a minute, but effectively we call a helper function on the protocol library that builds our 2-frame news message, and then we tell our publisher socket to send all frames of this message. So we're handing it, in this case, 2 frames. It could be n number of frames. Basically, send all takes a sequence of byte arrays and sends them off. So that's basically a very nice little flow. Wrap the handle into a message, into a series of frames, and then send it off on the socket.
Sorry,
Okay,
what's
so-
publish?
What?
Publish?
Publish is, if we come back up here,
Oh,
publish
okay.
is actually our publisher socket.
Yeah, thanks.
So technically, that's why I said this technically isn't entirely a pure function, because I am taking the closure and doing IO and whatever, but it's clean enough. Puritans to the back of the room, please. So then, now we're done with what's dead. We still have what's live. So before we do anything else with what's live, we go ahead and we see if there are any requests. So now we're back on our control socket. We poll up to our configured timeout for an input. Try poll input returns an option. If we have a value back from try poll input, we got a raw message. We again have a helper function that we'll go look at in a minute. This helper function takes a raw message and converts it into an internal type so that I have a strongly typed representation of my client request to work with. In fact, you guys want to look at that function now? That's fun. Let's do that. So basically, protocol.fs is all these little helpers that implement the protocol that I had on those slides before with that pseudo EBNF. And we'll get into all the details in a minute, but the important point is we parse a raw byte array into an instance of this union, because a request from the client is either going to be a valid here request, it's going to be a valid talk request, or something's going to have gone wrong, and so we return an error. What we actually do to get there is, where's my parse function? Parse raw message, or parse request. Basically, we do a little bit of pattern matching. Not everybody knows this. You can actually pattern match on arrays in F# and decompose to the full shape of the array. There's no splatting to catch like all the remaining frames, which I think would be a cool feature. Might be possible to do it with an active pattern. I haven't thought about that one. We don't need it here because we know our messages have a fixed length. Our messages are either 3 frames or they're 4 frames. If they're anything else, they're an invalid message and we don't care about them. So working backwards, if they're an invalid message, we create an instance of the fail case. with a new invalid message exception, and we just put the original raw message in the exception in case we want it for diagnostic purposes. So looking at our three-frame case, our three-frame case is going to be a here message, so it's going to be the client's identity, our routing envelope, basically the client identity and the empty frame. It's the first two frames of our message for router dealer. And then the third frame would be the actual here control frame. I've gone ahead and defined here as an active pattern, and this from active pattern basically takes that routing envelope frame and does two things with it. So the frame is raw bytes. We need to preserve those raw bytes because we are going to stick that back onto our response to send it back. But we also want to decode those raw bytes into the user's actual handle because I didn't feel like indexing my map with a byte array, so the key in my map is a string, so we decode from the, this is what you were asking about before, Ashley. We actually take that frame and do something with it and use it as actual data. And so this active pattern just bundles, it takes one thing and basically turns it into a tuple. The here that we're seeing here, the here active pattern, is actually a specialized partial application of this control active pattern, which does some basic validation on a single frame. Remember, all of our control frames are 8 bytes, where the first 7 bytes are pretty consistent and mean something particular. The 8th byte is the actual request being made. And so we just validate that. We check that the frame is in fact 8 bytes wide, and that the first 2 bytes are our signature, the 3rd byte is our version, the next 4 bytes are our protocol, and the last byte is some actual value. And here we just match against that value so we can easily partially apply it down here to say, control is when, or here is when everything else is true, and that last byte is 1. Talk is when everything else is true, and that last byte is 3. All right, so pretty straightforward. These guys, signature, version, protocol. Version is actually a literal. It's just a literal byte for the actual version. These guys, we can't actually do literals for byte arrays because they're not constant values because of initialization reasons. But we can cheat and just use this convenient shorthand, taking a string, suffixing a capital B on it, automatically turns it into an ASCII byte array of those characters because ASCII sits inside of UTF-8. Boom, there you go. I don't have to spell out the bytes. When I do this code in C# or VB, I can't do this. I have to actually spell out a byte array of, oh crap, was it 4D, 47, that thing. So we cheat here. This makes doing byte level stuff in F# kind of nice and easy. Yeah.
Is there a way to make it fill out an array or struct for you?
In what context?
Like you give it the memory to put the stuff into instead of it handing you bytes?
Not at the ZeroMQ level. You would have to add that. I've played around with that a few times. It tends to go a little, actually, no, I take that back. The API doesn't currently support it, but we could. ZeroMQ isn't stopping you from doing that. FSZeroMQ could have an API to do that. It just doesn't currently, but it could. It'd be a little tricky because what actually happens is at the ZeroMQ level, there is actually a message struct there's a C struct for message that I actually do load up into an F# struct. And then I turn that into I pull the byte array out of that. So we could add a layer that you give me a struct and I blast it in for you. But I didn't think that way when I wrote this in 2011, so it's not there now. But it's a good idea. I will make a note of it. That actually is a really good idea for an API. But it won't work with struct unions. Blast marshalling, like you would do with structs, is not supported for struct unions because of the actual IL they emit. It's sort of a pain, but like all of the marshal functions that take a struct don't work with struct unions.
It's annoying.
Might work with single case struct unions. Does not work with multi-case struct unions. I've actually got an open bug about it. Don was like, yeah, not gonna fix. Works great with struct records though. So there's that at least. Okay, where was I? So that's basically here. If all of our active patterns line up, we have an instance of here, and we return back the 2 pieces of information we need. The client identity frame from the routing envelope, and the decoded string that is the client's handle, which becomes the key to our map. Our talk looks very similar, except that after our control frame, we have one more frame that here I'm just binding to the raw byte array to a variable called message, because then I'm using, I'm decoding the byte array from UTF-8 to a string, and then using f-sharp.data to parse that JSON string. And I have my try-catch here, because obviously I could get something that's not decodable, or I could get something that's malformed JSON. If I do get something that's malformed, I catch the error, create a fail instance. Otherwise, I create an instance of the talk case, passing it all the data that I got out of it, well, all the data. The data I got from the routing envelope, and then the 2 pieces of data I got from the JSON. For people who haven't seen f-sharp.data, it's actually pretty cool. Basically, I give it a prototype of what the JSON should look like, and it uses type providers to automatically generate all the plumbing I need to both consume and emit JSON in that shape. So I use the provider to create my instance, and then I have strongly typed access to those properties down here, assuming my parse didn't blow up in my face. So that's basically how we turn a raw, byte array of byte array into an instance of this union. Bonus points, no comparison, is because I've got my warning level turned up to 5, and errors do not support the comparison constraint. So that's what we do here. Coming back into our actual server, our loop of our server, we basically poll for a raw message. If we get a raw message, we parse it into an instance of this union. That's what request now is. So once we have an instance of that union, we have an option really. We basically match that, and based on the tag, based on which case the union is in, we're going to produce a tuple of 4 values. The values are going to vary depending on which case we're in. So if we didn't actually get a request, we timed out, we didn't get a request, we're going to emit a diagnostic message. The clients who survived our culling at the start of this loop just get returned as is, and we just pass none for these other 2 values. Then we come into the interesting cases, the sum cases, meaning we got a message and we're able to parse it into one of our 3 union cases. In the case of our fail, there's not much to do. We create a diagnostic message. We again return the clients which survived culling. We return the diagnostic message, and we still return none respectively for the last 2 values of our tuple. So now then we get to talk and hear. Talk and hear follow similar patterns. What does talk do? Well, we got a valid request from a client, so the very first thing we're going to do is we're going to update our list of live clients so that this client gets their expiry extended, because they've communicated with us, so we should make sure we don't, count them towards expired. And I just created a little, I'm normally against custom operators. I'm normally very against them. In this particular case, add seconds was just annoying me because I had to do now, got to add seconds, right? So, blah, 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 blah. So I think plus equals in this case, also because client lease has a unit of measure on it, this saves me the trouble of having to also strip off unit of measure to call add seconds, yada, yada. So, we could see the definition of plus equals. In this case, I actually think it's not a terribly unreasonable use of a custom. Can you move to scroll up, Rick? Is that?
No, I see it.
It's not a terribly unreasonable use of a custom operator confined entirely to the privates of my library. It's not in my public API of anything, so yeah. No, I would never equivocate. So, okay, once we've extended our client, we create a diagnostic message. We go ahead and we actually send a news message. We broadcast this message because the client has requested that we relay their message to either the group or to a specific person. That's what the target property here that we pulled out is. So handle would be the client who sent us the message. Note, we don't actually care about the routing identity here because we're not sending a response to them, so we don't need it. And the details of the content of the message. We again lean on protocol a little bit. We have this build news message function, which we have these 2 functions, build list message and build news message. Build news message takes the inputs it needs, and it constructs the 2-frame binary message that we're ultimately going to broadcast on the publisher, where the first frame is the individual elements of our topic, right? The signature, the version of the protocol, and then the target, which, if we followed our protocol correctly, should be either $chatserve or it should be a handle. The payload is, again, we use JSON.NET. We just, it gives you functions for emitting not JSON.NET. Ooh, Freudian slip. F-sharp.data. It gives you functions for emitting the JSON as well as parsing it. So we emit the JSON, we encode it in UTF-8, and now, boom, we've got our binary payload. There's our 2 frames. We've got our little comprehension for building our topic frame, and everything is hunky-dory. Yes?
Why do you do that instead of concat?
Why do I do that instead of concat? Not any really good reason. I think this reads slightly better.
Also versions with single characters. So.
Yeah, that's the other thing. I mean, I could easily wrap that into a byte array, but then the 618F doesn't do that.
Gotcha.
So once we've actually constructed our message, you'll now notice we've got our updated user state, our diagnostic message, and now rather than none, we have some news message. We have some message to be broadcast. We still have none for our last value. And then we'll come look at what we do if we have a here message. We again extend our client because client says it's a valid message. We should extend their expiry. We again construct a diagnostic message because it's nice to see the handy little readout of what's going on. We like that. Then this part is interesting. We construct a news message, a message to be broadcast, if the client who sent us this here message wasn't already in our state of tracked clients. Basically, this is our welcome message. This is our greeting. And so, pretty simple. We check if the handle is contained in the currently live clients. If it is, then we return none. If it's not, then we construct a welcome message using the exact same logic we used for constructing a goodbye message, except that the message is welcome rather than goodbye. Pretty simple. So now we have an option here that's either none or some nested byte array, array of byte arrays. And then we construct our actual reply. Because remember, they've sent us a here. They've sent us our heartbeat message. We've said we're going to send them back a 4-frame message with the actual people who are currently alive. And so we do that. We take the live map, we pull out the keys, we turn it into an array, we pass it to the build list message helper function in protocol, which works very similar to build news message. We again have some JSON via F-sharp data. We create and encode our JSON, and then we go ahead and we construct our multi-frame message, our multi-part message, where here I didn't go for some long format, I went for something concise. The first frame is the target we're sending it to, then the empty frame tells us we're delimiting the routing envelope, then we create our control frame. I probably could have lifted this out to a constant value because, well, not a constant value, but I probably could have gone ahead and lifted this out because it's only defined once, but hopefully a good compiler recognizes that and lifts it for me. Who needs optimizations in your compiler as long as you get higher kind of types? Sorry, I nitpick about things. And then the actual last frame is the binary payload. So, pretty simple. That goes, so here news is the thing we constructed here, and here we have some reply. So, coming back up here, we've created these 4 values, a updated map, a diagnostic message, a potentially broadcast message, and potentially a response to the client. Once we have these 4 things, we perform I/O as needed. We emit our trace message, whatever it happens to be. We use option iter basically as a cheap, if-then. If we have a broadcast message, we publish it. If we have a response, we send it back to the client. And then we fall into our next loop where, going back to our loop state, we call UTC now to get the next iteration of the clock, and we pass our updated map of users to the loop. And that's basically the whole server in a nutshell. Questions? Sorry, let me scroll back to the There. Wow. That means means I either did a really good job or everybody fell asleep 10 minutes ago. Awesome. Either way, it's awesome.
That's cool.
I have to be honest, I don't know that I love the way that this is written. This is the 4th or 5th time I've written this server, and every time it's a little bit different. I've written it purely procedurally with a dictionary and a while loop. I've written it with a bunch of asyncs and a bunch of mailbox processors and shuttling messages around. I've written it this way. I wrote it a variant of this way, but instead of accumulating up those 4 values into a tuple and then acting on them, I acted on them in place when I encountered them. I've written it a lot of different ways. I honestly don't know that any one way works better in my mind for my purposes. I've not found an implementation that I find to be my favorite.
This is good for talks because you're not using a lot of fancy features.
Yeah.
That was sort of my thought is this demos very nicely, and this at least keeps to that functional mantra of modeling all your problems as a mapping from input to output. Like it's a very staged thing, like we do this with the input, and it gives us that output, and that output becomes the input to this thing, which becomes that, it's that very staged sort of pipeline, so I do kind of like that about it. I read a bunch of Mark Seaman
I was gonna say, Mark Seaman did pretty cool now.
Scott Blashin stuff, and I could not figure out a way to make this more pure. So, I mean, I'm sure there is, I can pull things out further, and I actually did have a version that was much more pure where I pulled everything out. What I had was a bunch of like 4 or 5 dedicated one-line functions that each did my I/O, because I only have about a line of, 4 lines of I/O in the whole thing. And then my main loop took like 12 inputs. And I looked at that and I was like, that's not really any better.
Basically, you could take everything from let live dead down to where you start the I/O stuff, factor that up, and then have the dirty function.
That's what I did.
Yeah.
That's exactly what I originally did. But that loop function, or the function where there was no I/O, had like 12, not 12, but it had like 8 inputs, and it was a bit wonky. And then what I did was I made some of those inputs higher order functions, where the higher order function was actually closing over the I/O, and I didn't like that. Got very messy to sort of logically trace the flow of.
Make a record and pass it over.
Yeah, and then you've got a record, but then you've got.
So actually, I've attended so like sometimes I find myself like writing these functions that have like 12 inputs. Sometimes I wonder, should I just like wrap them up in a record, or should I just create like smaller functions that, I don't know.
And I'm sure someone somewhere has, and in fact I know people who would recommend, no, what you really need is a custom implementation of the reader monad, so that you can read them out of your environment state, but only when you need that one actual piece of information. So like, yes. And then somebody else would say, well, what's wrong with dependency injection? Just spin up an inject or Unity or whatever. Which, okay, I'm not going to get into a fight with the DI people except to say MEF is not a DI container. Don't use MEF for DI. Done. MEF is a plugin framework for Visual Studio, and really don't use it for anything else.
What does map stand for?
I don't remember now. It's the, I forget, but it's basically.
I think it's a
the
managed extensibility framework or
That's
something like
it,
that.
yeah. It's the plugin system for Visual Studio.
Oh, okay.
But some clever people were like, oh, it looks just like a DI container. Well, because everything looks like a DI container at some level, in the same way that everything looks like a monad at some level. Except for applicative parsing, which doesn't look at all like a monad because it's applicative. Anyway, so yeah, this is good conversation. If people have thoughts on this, I am going to make this code public at some point. Like I said, the C# version, like I did the C# version a couple of different ways of this too, and in the end in C# I found it was easiest to just have a dictionary and a while loop and be done with it, but that's C# for you.
Which is why it looks like that.
Yes. So yeah, that's basically that. I can show you the client if you want to look at the client code. The client code does not look anything like this for several reasons. One, it was supposed to be in VB, but due to a number of scheduling problems, it's actually in C#. Two, it uses ZeroMQ, but that's it. It uses a very different project structure otherwise. 3, I am in post-production on an online training course using ZeroMQ and C#. And so I can show you the code if you want, but we should probably turn the video off because I don't want to run afoul of any IP agreements I may or may not have signed. So, but that's what that WPF thing that I was running before, that is actually all C#. But What's cool about it is it demonstrates the point that you can mix and match. Not only can you mix and match technologies, the protocols are a nice evolutionary device. The protocol as it stands, so the first version of the server and the C# version had slightly different protocols. I wanted to reuse the C# version. All I did was come into this server and tweak literally 2 or 3 things in my protocol file, and then boom, there I go. So you get the having those specifications does give you a nice layer of decoupling, a nice evolutionary mechanism that you do kind of lose out on if you have systems like, say, and I'm not criticizing because I do think these are cool systems, things like Cloud Haskell or Embrace, where you don't really have this decoupling mechanism and you're really bought into what the type system can do, and you need specific type system features and compiler features to get a distributed behavior. So there's trade-offs, is I guess what I'm saying. I'm not being critical, I'm just saying there are trade-offs. Closed system versus open system.
Well, it's a higher level thing.
Yeah, they're
You're
different purposes.
basically handing it a computation and saying, do what you will.
Interesting thing about that, a gentleman in the F# community, who some of you may know, named Ross, pinged me the other day. We were chatting on Slack, not chatting on my chat program, to tell me he started using ZeroMQ to do a distributed computation system where you build computations in Racket, capture the closure, send the closure over the wire via ZMQ, where D then decodes and evaluates the computation. So I thought that was interesting because it's basically Embrace or Cloud Haskell, but with Racket and D connected via ZeroMQ. I was like, wow, nifty.
What about dependencies?
Well, I imagine, I didn't get into a lot of detail with him. I imagine it's probably
Because
something very
that's
simple.
vagabond and
Yeah, and that's
a game
really
changer.
that's the interesting part when you start shipping computations around is managing all that infrastructure. In much the same way that microservices are not really interesting, it's how you manage all the infrastructure around microservices that actually becomes the interesting bit. You know, same sort of idea. Also, I'm not kidding when I said on that slide before that people have used ZeroMQ to build microservices frameworks, lest you believe that you must send microservices over HTTP. Not that you can't, just that it's not the only way. So if there are no more questions about the code, I have my obligatory closing slide. Peter Hitchens, who passed last year, who was one of the founders of ZeroMQ, has this great quote, and you don't have to read the whole thing, but the last sentence really sort of sums up the logical model. Scalable multi-core applications built as asynchronous message processing tasks. You do have this nice asynchronous thing going on. And then some links if you want more about ZMQ or FSZMQ. We could also go back to the code. We should just turn the video off if we do. Yeah.
I got a question. How do you usually do like service discovery?
So that's interesting. There's a couple of ways. So remember before we were talking about putting those intermediaries in it, the router dealer intermediaries or XPub, XSub intermediaries. One way is to just cheat and say, you know what, I have 1 or 2 known, stable, fixed points with well-known addresses, and that's that. And let the proxy manage just piping things about. The other way to do it is
If you hand off a socket through an intermediary?
you can. It's complicated. You wouldn't normally hand off a socket because that gets touchy, especially because sockets aren't necessarily thread safe. But what you can do with an intermediary is read a message in and then pass the message along. I mean, that's how the intermediaries basically works. They shuffle messages from A to B. And because when you're using router dealer, you have this routing envelope, you can do anything you want. So I could spin up, for instance, a farm of, say, 5 or 6 or a dozen workers, and I could take arbitrary client requests, look at the routing envelope, and do round robin routing to workers, do least recently used, do some other algorithm. So at some level, I mean that's sort of getting a little off topic. In terms of discovery, at some level, you either build a device to do sort of discovery for you, sort of like UDDI, kind of like a device that has sort of an intermediate state that in effect, that's what we were doing in chat here, right? Like, you've got this thing in the middle that is a known point, and it keeps some state about what's out there. Certainly, there's nothing wrong with doing like a handoff model. Like a lot of times, you'll pass the message directly through a broker, like we did, from client to client. But there's nothing wrong with a handoff model. There's nothing wrong with a server sitting there pinging a sort of a directory saying, hey, I'm available at this address and I take these messages, and then some client says, hey, do you have anything that takes these messages, give me their address, and then having that intermediary hand off the address, and then the other two nodes can make a point-to-point connection. That just is a lot, it's a bit more messaging to work, a bit more orchestration to set up, but you could do that. I've done that, I've seen people do that before, I've done that before. It's a lot of times just easier to have an intermediary, rather than handing off the connection information, have an intermediary just pass messages directly and be a proxy. But you can certainly, in fact, if you look at, I want to say it's Zyre, is a protocol that does something sort of like that. It's a completely pure mesh protocol. There is no server. So what they do is, it's not part of ZeroMQ per se, but they use UDP to create beacons, and then you just, everything that's on the part of the beacon is a binding address, and anything that picks up your beacon can then connect to your binding address to create a pure mesh. So that's another way of handling it. I've actually played around with writing my own beacon to do that, and it's interesting because the .NET socket interface is the definition of Byzantine, but it's an interesting model to see where, okay, I've got this little beacon, and even if you just limit it to like the same subnet, like that's very interesting to walk into a room and just randomly have devices start to connect to each other kind of thing. So that's sort of Zyre. It's a protocol that built on top of ZeroMQ that does that. You can look at. That's another way of handling it potentially. So there are some options, but it does require some work. There's, which I'm surprised nobody has asked. Usually I get some question about like, well, why wouldn't I just use Rabbit, or why wouldn't I just use Tibco, or why, and the truth is, there are different kinds of products that serve different purposes for different reasons. If, there are things that require you to do less work to get discovery, for instance, out of the box. A lot of the stuff that's built into Azure or AWS, a lot of that mechanics, it's really great because the discovery is very, very much thought out for you already. If you like its semantics, if it meets your needs, that's great. Similarly, I get a lot of questions. Well, we're not gonna, we can have a discussion about reliable messaging if you want, but I get a lot of questions about, what do you mean it doesn't write to disk? What happens if there's fail? How do we have failure? We could have that whole conversation, but like, that's maybe something you reach to another product for. Although, honestly, it's fairly simple to take a router dealer proxy, stick a circular buffer under it, and dump things to disk, and there you go. Like, that's not really the most complicated thing. Yeah?
Are there packages that other people do that layer on top that do those things?
There are. There's different projects. One of them that's sort of interesting is called Malamute, which sort of does that. It tries to combine a bunch of different things you might find in a more enterprise-grade sort of messaging system built on top of ZeroMQ. There's a project that I'm forgetting the name of now, but it's basically a company got seed money to basically do that Zyre thing that I was talking about, to incorporate that with some of the more standard patterns in ZeroMQ and actually build production-grade tooling for EdgeNet stuff. But yeah, certainly you can build additional things on top. Earlier versions of ZeroMQ, so we didn't cover this, but there's proxies are so common that there's a built-in call, it's a ZeroMQ call proxy that lets you stick two sockets together and it automatically does the shuffling for you. It used to actually support a mode that wrote out to disk. They decided that they couldn't get the semantics right on it, so they gave up on it. Once upon a time, an early version of ZeroMQ, like I guess it was version 1, maybe or version 2 of libZeroMQ, sockets did actually write to disk for recovery purposes, for crash purposes. You could actually set a tunable value, and up to some number of bytes, it would write. At first they did bytes, and they tried messages, then they went back to bytes, and then went back to they eventually abandoned it because they couldn't get the behavior predictable enough. It needed too much fine-tuning for too many different situations, but they actually tried that for a while, having sockets that do write to disk for recovery. And the truth is, sometimes it's reasonable, but making it a built-in feature means that now you've automatically disenfranchised people who are willing to give up the rights to gain more throughput. So ZeroMQ's approach is go the opposite way. Lowest common denominator, don't have it, but make it easy enough to layer it on top, which you certainly can. For instance, all of the proxy functionality can take an optional third. So the way a proxy works, you give it two sockets and it just shuffles messages between them. You can give it an optional third socket, and that socket sees a copy of every message. So you could easily have the other end of that socket be something that is writing to disk if you could tolerate the I/O latency. It could be shutting it in SQL Server if you really could tolerate the I/O latency, that sort of stuff. Not that writing to SQL is inherently slow, just that databases by definition incur slower I/O than simple disk I/O.
So speaking about all of these different modes of operation and tuning, what sorts of instrumentation does ZeroMQ have?
Out of the box, nothing, but it does play well with Valgrind for memory processing. On Windows, I actually get pretty far tuning it with two tools from sysinternals, a Proc Explorer and VMNAP.
Okay.
Because those are the things you're really worried about, right, with data process. Like, is it burning memory? Am I leaking, or am I stopping? On occasion, because it's a C library, you pull up WinDebug and poke around a little bit. On the .NET side, on the FSZeroMQ side, the standard .NET profiling tools, benchmark.net, stuff from Redgate, that sort of stuff. So.
What about message tracing, stuff like that, just looking on the side, seeing if something's receiving?
I did not cover this. I did cover it in my course. I did not cover it here. There's a feature called socket monitors, which basically lets you throw an additional pipe on the side of a socket, and then you will receive lifecycle events for that socket.
Cool.
Usually what you do is you hook one of those up to a dedicated thread in your application and in-process thing, and then it gets the events. Oh, connected. Oh, client 2 connected, that sort of stuff. So,
Yeah.
But that just gives you a rudimentary lifecycle of the socket. That's not going to help you with routing a message through, like debugging routing a message through is a bit more.
Yeah, I was just curious how far it stepped in. It seems to be very conservative, which is fine.
Yeah, it doesn't go very far. It's sort of like if you think about the traditional network layering, and I never remember, do you count from 1 up to 7, or do you count from 7 from 1 down to 7? Well, anyway, it sits just above 7 is sort of what I think about it.
Yeah.
So you get a little bit more than you would get if you were at the raw socket layer, but you don't get a full, dtrace sweep on top of it or
Yeah.
anything like that.
Yeah.
Although you can, because it's a libZeroMQ is a C library, if you're, for instance, doing it on you can use dtrace or whatever Apple's pretty GUI-ified version of dtrace is.
Instruments,
Yeah, it works with that, but that's at the C library level. Obviously, at the FSZeroMQ
Do they actually define dtrace probes, or you just have to do function call boundaries?
Definitely function call boundaries work. That's all I've done with it. I haven't looked into if dtrace probes are actually defined or not. I do know also Valgrind support is in there, but only because I've seen the if-defs in the code. I honestly haven't spent a ton of time performance tuning at that level. Usually the performance tuning I'll do with it is more at the end-to-end level. Hey, I know messages are flowing. I'm able to just, I see that messages are flowing. For my overall response, application process, am I getting fast enough throughput? What kind of latency am I getting?
Yeah.
The core libZeroMQ source and FSZeroMQ ship with independent executables that let you profile that, but it's not detailed profiling. It's a simple executable that lets you measure throughput. You give it how big a message should be, how many messages you want to send, and it'll do it'll run a test to say, okay, your throughput was X, your latency was Y, kind of thing. So that's a nice, but that's just added as a separate. It's not part of ZeroMQ itself. It's just a separate executable that's shipped with the code.
Cool.
So, yes.
Question. I think near the beginning of your talk, when you first brought up dealer router, you were going to mention why they call it dealer router.
No, just
Oh,
there was no resort. They actually used to be called XREP and XREC, and people got tired of XREP and XREC, and so they decided to relearn that router and
it's
dealer
kind of
made
like
more sense.
Quark names, right? It's just like random, strange
Yeah.
char, whatever.
And there's a bunch of others. They used to be fairly intuitive. There's push-pull, there's pair, there's stream, there's client-server, there's radio dish. There's at some point you run out of good names and the role names start to become a little nebulous. Okay, so but yeah, there's not a real good reason for why they're called router and dealer. Or I should say the one person on earth who could probably tell you is dead. So.
And also, I have another question too. You went over some of the major roles, especially as it applies to this, but what are the other?
So some of the other ones would be pair sockets forms an exclusive pair between two sockets. You typically only use that for in-process communication stuff.
Okay.
Again, like diagnostics, or like you have a proxy where, in addition to a capture port for capturing messages, you have a control port where you can spin up an in-process pair socket to stop and start it from another thread, that sort of stuff. Push-pull doesn't get used a whole lot. Think of it as pub sub without the filter. It's direct, one-way blast messaging.
Mhm.
But what's nice about it is the way the fan in and fan out and other features are set up. You can do really simple and easy sort of like MapReduce style things with it. Like it's set up for, hey, this thing is producing values. They're going to these n number of things in the middle that are going to process things and then collect it down in the sink. The problem why people don't use it a lot, it performs very well, but you're responsible for coordination of that intermediate level. So you need another channel or some sort of mechanism for synchronizing. Otherwise, you get too many messages go to the first node. You get to sort of a distribution issue. But that's another one. Stream is very interesting. Stream is basically a raw socket. You use Stream to interface directly with TCP sockets, which people have put to good use for things like fronting WebSockets directly onto ZeroMQ and fronting HTTP onto ZeroMQ and things like that. So there are a few other different kinds as well that I'm blanking on at the moment. Those are all the major ones. But you get actually really, really far, truthfully, with just router and dealer. Like even as useful as PubSub is, and PubSub is very useful, there are still scenarios where it's like, I could do this in PubSub, yeah, or I could just do it with router dealer. Like you can actually get really far with them. So because it turns out one of the nice properties about ZeroMQ is you can tune the hell out of it and get very, very like brutally, amazingly fast performance out of it. But even sort of just using it sort of naively, the way the API guides you, you get kind of decent performance. And that's kind of a nice thing when a tool sort of works pretty good without you doing anything special. You know what I mean? So, additional questions? We're almost at time. I want to thank you. You have been fantastic. This is a great, hopefully not my last appearance here, but certainly my last official appearance as an organizer of this group. It's been an awesome, I guess it's been 6 years now, Rick, right? 7, yeah, you're right, 7, yeah, 7. So it's been a long time. Oh, one other thing, shameless plug. I've already shamelessly plugged my online learning course, which is going to be through LinkedIn Learning. If you, whatever, it should be out in a couple of months. If you're interested in ZeroMQ and C#, I doubt you are because you're in this group. But other shameless plug, FSZMQ has been in active development and deployed in production in multiple places since 2011. So it's fairly stable. I mean, I'm not going to say it's bulletproof. I'm not going to say you wouldn't find a bug, but this is not something that I cooked up over the weekend, and I'm hoping catches on. It's a real library. I feel the need to put that out there because people are like, well, oh, but it hasn't seen an active commit in like 3 weeks. Well, yes, because over time, your year over commits should decrease and should level out because your library should become stable. You know, like read between the noise. So put that out there. But yeah, this has been fantastic, and thank you so much. And